Hey, good morning, good afternoon, and good evening, everyone. Thank you for joining us. A big thanks to Everest Group for co hosting this session with us. I'm Kirti from Zuci Systems, and I'll be a moderator. So it's great to see so many testing and AI leaders joining us. Thanks again. So today's session is about QE for AI, testing probabilistic systems deterministically. The focus is simple, right? As AI becomes central for enterprise workflows, ensuring their reliability is no longer optional. Unlike traditional software systems, AI does not produce the same output twice, so which makes validation and trust very important and a real challenge. So, in this session, our speakers will walk you through how organizations are approaching output AI output quality of AI systems, what's changing in testing practices and space, and what it takes to build confidence at scale. So we'll also take a look at a real enterprise example followed by a Q&A session at the end. So before we dive in, we have a few housekeeping announcements. So feel free to type your questions in the Q&A window anytime during the webinar. We'll collect them and take it up at the end of the session. We have a dedicated Q&A window, 10-minute window at the end of the session. Also, you'll receive this webinar recording and an in-depth white paper. Both will be shared to you over email. You can look forward to it. Yeah. All right. Then let's meet the speakers. I'm joined by three leaders who bring complementary perspectives on this evolving space. Firstly, I'm joined by Ankit Nath. Ankit is a practice director at Everest Group, our research partner for today. Everest has been deeply studying the intersection of AI adoption, quality, and enterprise trust governance across global enterprises. And next, we have Srinivasan Sundaram. Srini heads Gen AI Center of Excellence at Suchi. Srini has been working closely with our enterprise clients in operationalizing AI solutions for them and building trust into their production systems. And lastly, we have Sujata Sugumaran. She heads QE at Suchi. Sujata has been at the forefront of evolving QE practices in order to meet the demands of AI driven systems and right from building testing frameworks to assuring models. So, with that, let me hand it over to Srini. Over to you, Srini.
Thank you, Kirti. Hello, everyone. Good morning, good afternoon, and good evening. Our journey in AI started almost a decade ago when we began building our classical AI solutions based on machine learning models for our customers. Even back then, the challenges were one, accuracy, and the other one was explainability. Accuracy more related to accuracy of the output, model outputs, but explainability is more about explaining why the model behaved in a certain way they did. For example, we built loan default prediction models for banking customers. When the model produced a default score for a loan applicant, it was often difficult to explain how that score was derived, especially to say a loan officer. Showing him a score, and when he asked a question like, "Why is the score a 79?" It was always difficult to explain the rationale behind it, and even more so when for the same customer there were different scores at different points in time. This lack of explainability actually started, it kind of eroded the trust. Fast forward to today, in the world of Gen AI, the same problem has multiplied with new dimensions of variability. Gen AI today, one of the bigger problems or one of the unique problems is the reproducibility, right? So for the same prompt at different times, you get different outputs. While this is not a defect, it's more of a feature, I would say, in a Gen AI system because they are probabilistic in nature. So they continue to evolve, they continue to predict a different token each time. But for a end user, this kind of erodes trust even further. So you have multiple such unique elements for a probabilistic system that continues to expand this or widen this trust deficit. And even more so when you go into a multi-agentic AI system today, where an output of one agent becomes the input for the other agent, the small variance in the upstream agent actually creates a domino effect and cascades and create a very high amplitude in variance. It is a proven research-based data point that LLMs have a minimum of about 15% variance in its reproducibility. Right. So these are the different challenges that the end users are facing today, which is widening the trust gap. And as you see in the screen, even Everest Group notes ensuring the quality and reliability of AI system has become one of the biggest challenges for enterprises today. So in this webinar, we'll talk about how we can address this assurance challenge and how quality engineering must evolve to make these probabilistic systems more testable, measurable, and trustworthy. In this webinar, some of the key takeaways that you as audience will get is, one, we will be focusing on a QE assurance framework, which we have derived over the last few years of our experience testing these system. Two, we will be talking about the new quality dimensions that we have to adopt or we have to use to assure quality for these systems. And three, the different QE approaches. While we call probabilistic systems as a single unit, but actually in reality, probabilistic systems are multiple kinds, and each of these systems will need a different approach, right? So that's something that we will cover today. Yeah. So, but before I go any further, I would just take a step back and I would like to understand what Everest Group sees in terms of enterprise adoption of AI. So, Ankit, what do you think? How the enterprises are doing? How are they adopting AI today?
Yeah, I think thank you, Srini. That's a very important question for us to understand because what we have seen uniformly is enterprises across the board, right? They understand the importance of AI, and if I talk specifically about Gen AI, what we have seen back in 2024 is 70% of generative Gen AI initiatives that didn't move from pilot to production. Yet, come 2025, we didn't see any AI or Gen AI initiatives slowing down at all, right? In fact, on the contrary, it only increased, right? The biggest adopters have been enterprises from BFSI, HLS, RCPG segment. Think of use cases like wealth management, fraud detection, drug discovery, clinical documentation, right? But if I sort of take a step back and try to discern the pattern of AI adoption or how enterprises are consuming across various of these use cases, case studies, I'll probably come to these distinctive buckets that you see in front of your screen here, right? The first would be individual AI. As the name suggests, it is for augmentation of individual capability and capacity, right? Think of individual employee working with tools such as ChatGPT, Perplexity, or any AI tool. Now, if we were to sort of expand the net of AI's influence from, let's say, an individual to a team, you have what you may call as tech stack AI. Think of AI systems such as Copilot, SAP Joule, Salesforce Einstein. Now, if we expand the net of AI's influence even further from, let's say, a team to multiple teams, we have what we call as systems of execution. Now, this is specifically about transforming multiple enterprise AI workflows that would not only span across multiple teams, but it would also be spanning across multiple workflows, multiple AI workflows, multiple processes and sub processes, right? And notice one interesting thing. For other kinds of AI consumption, the individual AI consumption or tech stack AI consumption, when we are talking about tech stack in those two categories, we're calling it key suppliers, right? But not the case with systems of execution. We're calling it key enablers because to enable a system of execution workflow, multiple types of tech stack and not just tech, right? It's about processes, it's about change, it's about people. All of that has to come together to operationalize systems of execution workflow, right? But net, the point that I'm trying to drive here with this slide, and perhaps that would be a good segue for us to talk about content in the subsequent slide, is irrespective of however enterprise consume AI, however they consume AI, right? There are risks to be considered. Enterprises are aware of those risks, but what we need to have a larger conversation about is how to mitigate those risks. So probably over to you, Srini, with that.
Great. Thanks for that insight, Ankit. So you spoke about multiple systems of execution, right? So can I assume that I mean all these different systems, I presume all of those are AI systems, ultimately have a or converge on a single constraint when it comes to scaling the need for a quality assurance framework that works for these probabilistic AA systems. Would you agree, Ankit?
Yeah, absolutely. Ultimately, what we are trying to solve for here is the trust deficit, right?
Mm.
Uh, it Things can go wrong even if the scope of influence is as limited to an individual or if it is about multiple teams, right? So I think the conversation that we need to definitely have about is how to solve for that trust deficit, right? What can quality function play as a role there, Srini?
Perfect. Perfect. Thanks a lot, Ankit. So yeah, with that, before we move on to how to solve this problem, let's look at why the traditional QE methods that we adopt for deterministic systems can't generally don't work for assuring AA systems, right? Uh, Traditionally, the QE frameworks were built for a closed world of certainty. When I say a closed world of certainty, what I mean is the requirements are clear. The requirements are documented as functional specs, where there are sets of inputs very well defined, and there are sets of outputs that are expected for those sets of inputs. And in a design document, the technical team draws the line, the code path from the in for every input to output. And in a QE world, these becomes, these are the information or the deterministic information that are already available. And the QE focuses on coverage, writing each of those code paths as a scenario, and then builds the test cases and build it, right? So here, what we are testing for is whether the same input, provides us, for a given input, are we getting the expected output? And whenever there is a difference or a variance, we call it as a defect. But when it comes to a probabilistic system, the all this clarity is not there, right? A requirement is there. We know that this is the requirement, but because the agentic and the LLM systems can behave in different ways, the same input can produce multiple outputs, right? And that's a reproductive or reproducibility problem that I explained before. So with this kind of scenario, testing these systems is not very easy for the deterministic scale, right? So that's where we have to have a need, or we have the need for having a QE assurance framework for the probabilistic systems. Right. So moving on, what we have done is that we have taken our experience building the machine learning models, the probabilistic systems, the multi-agentic AI solutions that we are building today. We have synthesized our experience in terms of testing these and providing quality assurance, and we have put together a AI framework for all our AI applications. So this AA framework has three major layers. The first layer is about system output quality, the quality of what the AA application produces, right? And this is what is visible to the end users. Right. Here, the key assurance factors in this layer are things like reproducibility, the factuality, drift, bias, etc. And this layer will be the focus of our webinar today. Beneath these layers, if you see, there are two other layers. The second layer is what we call as the cognitive capability quality. So this is a layer which focuses on the core capabilities of the AI itself, right? The AI applications have unique capabilities like reasoning, memory, collaboration, and ability to learn over time. So testing, quality assurance here is important because this reflects in the first part, which is the system output quality, right? Then we go to the third layer, which is the architectural and process quality, where the focus is on how is AI engineered for trust. Here we go deep into the engineering part of the AI system itself, where we focus on the deterministic part of AA system, things like observability, things like governance, continuous assurance, etc. Right? So all these three layers represent a complete framework for bridging that trust gap or trust deficit that Ankit said, and this enables the enterprises to scale AI confidently. If you look at it in a traditional AI or a testing setup or a QE setup, predominantly we focus on part one, or the first layer, which is the system output quality. But if you look at it, we are now actually moving away from just QE team being just the gatekeeper of the product quality at the end of the life cycle to actually managing this complete ecosystem, right? So they take a one step above and they assure the quality from an engineering standpoint, architectural standpoint, process standpoint, and the output quality standpoint itself, right? And this kind of change requires a complete change to say mindset, the tool set, and the skill set, which I believe Ankit will be talking to us. In fact, he will be talking about it in the later part of this webinar. Now, knowing that, okay, now we know that, I mean, the first part is the system output quality, which is what we are going to focus on today. How do we measure this, or how do we assure this system output quality? Here is where we are looking at it, or we are introducing 5 new dimensions, the new dimensions with which we will be measuring the system output quality. The first one is the reproducibility, which I already addressed it. It's the consistency of the results across repeated runs, or for the same prompt, how consistent the results are going to be, right? Reproducibility, or this variance, is a fact of life. It is a feature of any LLM system. So we can't remove variance from the GenAI systems. The quality functions work here is about defining the range, defining the thresholds, putting the guardrails, and ensuring the variance is limited and the variance is understood well, right? So that's the first dimension, which is reproducibility. The second one is the factuality. Factuality is nothing but how grounded the output of the AI system in terms of the data, in terms of the information that it ingests to produce that output. The third one is bias. When it comes to bias, generally we talk about the behavioral bias, but we also look at the systematic or the engineering bias, because more often than not, we have found that if the data is not widespread, if the data is skewed towards a certain part of the spectrum, or the prompts are not very well defined, the system starts to behave, starts to show some bias, right? So here we look for both the behavioral bias as well as the engineering bias. The fourth one is drift. It's very much like the regression that we see in deterministic systems, except that here, as the system evolves, as the new prompts get added, as the new data gets added, we measure, or we check that the application's output don't drift, right? And finally is the explainability. This is very important for GenAI systems, given that a lot of LLMs and the agents are black box in nature. We need to ensure that every output is traced back to its provenance in terms of the source of data, and every reasoning that an agent or an LLM used in producing that output is explainable, right? So this provides that the trust or the assurance to the end user. Right. So these are the 5 major dimensions that we will be looking at in terms of assuring the system output quality. If you look at it, the first 2 dimensions are more towards assurance of the quality of the application itself. The second 2, which is bias and drift, assures the integrity of the application. And finally, the last one, explainability, assures the accountability of the system, right? So these in total is what we use for assuring the system output quality. Now, now that we understand there are 5 different dimensions to assuring the system output quality, next we want to look at, okay, are these all equally applicable in all scenarios, right? And in our experience, we have found that the emphasis on each of these, the dimensions varies from system to system within the probabilistic space, right? So that is something that I would like Sujata, my colleague over here, to explain going forward. Over to you, Sujata.
Thanks, Srini. So, Srini just walked us through what defines AI quality, those 5 measurable trust dimensions. Let us now talk about how those dimensions show up differently depending on the kind of AI systems we are testing. Because not all AI systems behave the same way. Traditional software is quite simple and straightforward. 1 plus 1 is always 2. But in the AI world, 2 identical inputs can yield slightly different and sometimes even completely different outputs, yet they might be very valid ones. So that's where the determinism spectrum comes in. At one end of the spectrum, we have highly probabilistic, predictable system like credit scoring or invoice extraction, where output are almost deterministic. And at the other end of the spectrum, we have the very creative generative AI kind of systems like marketing copy or patient communication or story generation, where the system output produces endless variation. So same output can produce endless variation. So in between these two, there are reasoning and decision support systems that operate with different level of uncertainty. So the question becomes, if predictability varies, how do we test them? The answer is we don't use one testing method. We adapt our QA approach based on the level of determinism, moving from verification to validation to evaluation to assessment. Let's now take a closer look at each zone. At zone 1, we see the zone 1 represents the systems that are highly predictable in nature, such as machine learning classifiers, scoring models, and information extractors, which are very much structured, data driven, and measurable. Let me share a real time example here. A few years back, Suchi partnered with a large retail bank in their digital transformation journey. And as a part of the digitalization, we built predictive models for credit risk, churn, and product propensity scoring for the bank to make better decision and product placement. These models relied on historic data, fixed features, and deterministic algorithms. Still, the output was probabilistic to some level as they were predicting. So, when the systems were tested like traditional systems, it brought in the challenge of accuracy. The data quality and model stability was a greater threats. Frequent training caused output drift even when the logic hasn't changed at all. And we had to validate accuracy statistically, not just functionally. So, how did we test these systems? How did we approach the testing for these systems? So, we built golden data sets based on ground truth. These are curated samples where we used to test whether the model predictions are truly correct. We tested the model on past data from different time periods, the historical windows, to see how well it would have performed in real world past scenarios. And we monitored changes in the types of model errors after each retraining, like looking at the false positives and false negatives. Also, we built live dashboards that automatically compute and visualize key performance metrics like precision, recall, area under curve for ongoing model monitoring. This helped us moving the accuracy from 66% to 90%. So we can see that QE here is very much metrics driven. So the QE focus here is verification, and dominant quality dimensions are reproducibility and factuality. In nutshell, if I have to put together, zone 1 systems are like the well behaved AI student, where we just need to make sure it keeps scoring 90% after every retrain. Moving on to zone 2. Zone 2 is where things are start getting really very interesting. Here AI system begins to reason. They draw inference, make contextual decisions, or fill in the gaps with their judgment. So these systems don't always produce identical outputs, but their reasoning should be stable. So, let me talk about our engagement with a global insight provider, where we are helping them in building an agentic AI system for bid estimation that combines market data, supplier history, and also the reasoning. So the challenge here in testing are, multiple valid answers can exist. So the binary pass fail doesn't work at all. And we need to validate reasoning quality, not just the outcome. So the reasoning quality is really important here. Output must fall within a confidence band, not exact match. So it's all about consistency, rational, and explainability. So, how did we test these systems? So, we created high quality data sets by selecting and validating real historical bit data to serve as the reference for evaluating model generated outputs. We also designed a prompt testing framework, the prompt harness, that runs the same input scenario multiple times to measure how consistent the model responses are. We quantitatively compared how similar or different the multiple model outputs were using two well known NLP scores like BERT and RO. So, also, we captured internal model reasoning to understand why output differences occurred between runs. This helped in improving the explainability and debugging by identifying whether the variation came from, prompt ambiguity or data retrieval changes or the model randomness itself. Also, comparing model generated bid responses to those made by human experts to assess how close the model is to the expert level quality. And any low confident cases went to human reviewers with structured rational cards. So these all helped us in delivering bid estimations with 90% benchmark accuracy. Overall, if we look at the QE focus here was validation, and the dominant quality dimensions were reproducibility, factuality, and explainability. So if I were to sum up zone 2 systems like a smart, it's like a smart analyst, right? Usually they are usually right, sometimes debatable. Our role as a QE is to ensure those debates are explainable and statistically grounded. Moving on to zone 3. So here is where the AI begins to generate content. So it is not just predicting or reasoning, but actually start creating structured outputs. This could be a portfolio summary generator in the bank, a proposal policy summarizer in insurance, or a discharge summary assistant in healthcare. Here you will get multiple right answers, each parsed differently but still valid. So the challenge in testing here would be it's really hard to define a single ground truth. And the risk of hallucination is great here. The fluency would be there, but the text would be incorrect. So the need for human rubric for subjective aspects like clarity, tone, and completeness is also very much required. So the QE focus here is evaluation. We need to evaluate quality, not just the correctness. And the dominant quality dimensions here are factuality, bias, and explainability. That would help us answering, is it grounded in truth? Is it fair and balanced in tone and content? And can we trace which data or logic influence the results? Here we are mixing quantitative and qualitative validation. So basically, zone 3 systems are that brilliant writer in the team who will produce great summaries, but still we have to check the fact before publishing. And finally, moving into zone 4, the most open ended and creative systems. So, the thinking, think of the marketing or copy generation, marketing copyright generation, or customer communication drafting, or personalized finance coaching assistance. These systems are intentionally non deterministic. The goal isn't identicality, it's alignment with tone, brand, and ethics, right? So these are highly creative and open ended. So the challenge here in testing is infinite valid outputs is possible. You can't predefine what is the expected result should be. And bias and tone drift over time happens. It's harder to measure factual accuracy. Instead, we have to test the alignment and trustworthiness here. So the QE focus here is assessment, human in the loop testing, alignment scoring, and preference evaluation. Dominant quality dimensions here are bias, drift, and explainability. That ensures, fairness and inclusivity, detects deviation in tone or accuracy, and rational logging for transparency. Here, QE defines structured rubric for human evaluators, the creativity, empathy, clarity, turning subjectivity into measurable confidence. So, zone, zone 4 systems are like creative copywriters, expressive, unpredictable, and sometimes a little too bold. So, QE's job here is to keep that creativity on brand, compliant, and trusted. So, let's step back and look at the full picture. The determinism spectrum helps us tune quality engineering methods to match the type of AI systems we are testing. So we have discussed all four zones earlier. The zone 1 are the predictive systems that are, quite stable. And here we are going to focus on accuracy and reproducibility. At zone 2, if we look at, these are contextual and reason driven systems. So the focus for us would be always or mostly on explainability and reliability. And at zone 3, these are creative systems. So the focus is going to be on factuality and bias control. And finally, at zone 3, we have the creative systems where the focus is on alignment, ethics, and continuous trust validation. So, those five dimensions that Srini talked about earlier, reproducibility, factuality, bias, drift, and explainability, they stay the same, but their emphasis shifts with determinism. That's the continuum of trust engineering. The bigger message here is QE must evolve from testing the outputs to engineering the trust. So we no longer validate the code, we are actually validating the confidence and becoming the enabler for the business. And with that, I will now hand it over to Ankit, who will share his perspective on how the quality function itself needs to evolve from an assurance role to an enabler role for enterprise to scale AI adoption. Over to you, Ankit.
Thank you, Sujata. I think that was a good description of what quality function is expected to do in this evolved AI adoption era, right? You've talked about different zones of AI adoption, the deterministic, determinism, spectrum. We've talked about what is the expectation, right? But the larger question here is quality function even equipped to carry out this evolved mandate? The answer is unsurprisingly no. The reason is simple that you and Srini quite highlighted earlier, that we're not dealing with just deterministic outcomes anymore, which quality function, traditionally speaking, have always been used to test, right? We're talking about probabilistic outcomes, right? And solving for that isn't just about adopting a new tool per se, it's complete reimagination of how you approach, how you do quality, right? We're talking about rethinking skill set, rethinking how enterprises think about quality mindset, and also in addition to that, rethinking tool set. Let me talk about all of that one by one. I'll start with the skill set bit. If I sort of think about the skill set, right, the message that I want to give here is quite simple, that future ready QE teams, they'll need to have fluency across the AI stack. And now if you sort of lay out the AI stack, we are talking about data, we are talking about model, we are talking about application. Now, if I talk about where traditionally quality function was always focused in from a skill set standpoint, it is mostly to do with assuring applications, right? You're talking about skill sets such as UX testing, API testing, some bit of security testing as well. And of course, domain and regulatory knowledge comes there. But in order for a quality function to be equipped to do AI assurance, they will have to be broader in terms of the expertise that they possess. They'll need to have expertise in data assurance with skill sets such as data pre-processing and cleansing, bias detection in data sets. They'll also need to have expertise or at least a functional understanding of how to do model testing, model assurance, right? Think of adversarial testing, think of bias detection, think of understanding of interpretability techniques, right? Next, I'll move to the mindset bit. Uh, yeah, so to make my point here, I'll refer to an interesting research we carried out last year. The focus of that research was assuring the risk and reward of generative AI adoption. As part of that effort, we spoke with a lot of enterprises from different industry background, different geographies. Uh, Interestingly, or rather uninterestingly, a lot of enterprises said that, or rather, they thought of quality function as not so influential when it comes to assuring GenAI systems. They would say things like, I don't think quality function has a role to play in assuring AI systems. Some of them would say something like, they don't believe their quality function is senior or mature enough to even influence upstream decisions, right? But as part of that research effort, what we found interestingly was this handful of enterprises who would think otherwise. They would involve their quality function early on in their AI adoption cycle. And it's I mean, I'm not, don't get me wrong here, I'm not only talking about them involving just a quality function in AI assurance, right? It was a combination of their AI teams, data teams, as well as quality function playing their role right from the get-go. Now, here's the interesting part. These enterprises, these mature enterprises, they achieve 25% higher outcomes compared to enterprises who would think otherwise, right? Who would fall, or whose thought process would align with the left part of the slide that you see here, right? And when I say outcomes, I mean both strategic and operational outcomes out of their AI and GenAI initiatives. Now, what can we learn from these enterprises from a mindset standpoint, right? It's simply three things. These enterprises, they have a very deep focus in ensuring continuous innovation of their quality function, right? They are not tied or married to how quality function used to operate, let's say a couple of years ago. They are evolving their quality function as it needs to be the case, right? Uh, Couple that with the risk management aptitude that these enterprises have invested their time and effort in, which obviously manifests in how they even do quality. And then combining all of that with business and value assurance centricity from an accountability standpoint, and then you have a quality function that actually works in this, right? Uh, Again, I'll move to the tool set bit here, and the next part. Yeah. So now coming to the tools a bit, obviously a lot of what we have just talked about, there is a major or there's a major potential tool interplay. Now, if you sort of lay out the AI adoption cycle, that as you can see in your screen, you have assessment stage, you have implementation stage, you have post implementation stage, right? In the implementation stage, if you think of tool requirement, you would think of use cases such as assessment frameworks, risk assessment frameworks, or data quality tools. In the implementation part, you're probably thinking about tool support in the form of AI model validation platforms or integration testing tools. In that post-implementation stage, you're probably thinking about tool support in the form of model drift detection tool or continuous monitoring tool. Now, having said all of this, I just want to make one point clear. What we are not trying to say first, because we are not trying to say that all of this needs to be disparate set of tools, right? We are talking about, I mean, otherwise we are just introducing complexity. We're talking about 10 different tools for 10 different use cases. We're not saying that. We're talking about a platform centric approach to it, right? And we are also not saying is that you need to have 100% coverage from day one itself from a tool standpoint, because you don't need to. For instance, a lot of requirements here, let's say if I talk about the assessment stage here, can be handled as a project you either do in-house or you can outsource to some of your service provider partner, right? And then you slowly move to a tooling landscape when you see the value in doing so. But having said all of that, what we are definitely saying is a lot of this tooling landscape, it will obviously have AI infused automated workflows. Now, it need not be the case that every use case where you feel the need to do so, you'll need to invest in AI based automation, right? It depends on the repeatability, and that will depend on your context, right? So you'll have to take that into consideration, right? And obviously the ease of use, that needs to be a consideration here as well. So that is from a tool set part. What I'll do in the next couple of seconds is just quickly summarize what I've just said till now. So firstly, future readiness for an enterprise quality function. It is a function of how fast that they can move. We're calling it agility index. multiplied by the AI infusion, the impact of AI, right? And when I say AI, I mean it's a function of automation, it's a function of Gen AI, it's a function of agentic AI, it's all kinds of AI, right? Uh, Now, AI success in itself is a function of continuous persistent AI investment. And then you subtract that with the enterprise AI debt that you carry, be it process debt, be it tech debt, be it systems debt, be it data debt, right? To the power of QE, because quality function has a very, very important role to play in this case, right? And third, the quality function itself need to evolve, right? Which we have just talked about. It is a function of evolution in the form of skill set, mindset, and tool set, right? That's just a mathematical way of representing all this. I'll also invite Srini and Sujata here to sort of summarize Shuchi's point of view in this case.
Perfect. Thank you. Thanks, Ankit. So we looked at, from a practitioner standpoint, we looked at three major outcomes or takeaways in this discussion beyond what Ankit just suggested. The first one is the AI quality stack, right? Where we had looked at three layers of quality, starting with the visible quality, which is the system output quality. And then the two other layers below that, one is the cognitive capability of, quality assurance for the cognitive capability of the AI systems, like things like reasoning, retrievals, right, learning, all of those. And then the third one we looked at was the architectural process quality, which is basically going into the core engineering itself and looking at, ensuring that the assurance is provided at that level, right? So that's the first thing that we looked at, which is the Shuchi's quality framework for AI. The second one we looked at is the new dimensions of quality for the first layer, the system output quality. We spoke about reproducibility, the factuality, explainability, bias, drift, right? Why these five are important to bridge that the trust gap. And finally, Sujata beautifully explained about how, even though we call, AI systems, it's not just one system. It's actually depending on the nature of the work it does, it falls into a continuum, a kind of a spectrum, with highly deterministic systems at one end, which are predominantly the machine learning model systems, and highly probabilistic systems on the other end. One of the examples she gave is the marketing copy, right? So, and the probabilistic systems that we test or we assure quality can fall into each of in any of these zones in this spectrum. And the quality approach, the dimensions applied, all of those varies depending on where it falls, right? So that's something we discussed. So this uh, brings us to the end of the webinar, the presentation that we had in mind for you. Given that this is just a 45 minutes conversation that we had planned for you today, we touched upon a lot of important topics, but we didn't go deep into any of these due to the paucity of time. But however, we have explained this in a lot more detail in our white paper, and we will be sending you this white paper over email after this webinar is over. So I think now it's a time for us to open it up for Q&A. Even if we can't finish all your questions in the next 15 minutes or so, you can always write to us, and we'll be happy to set up a call or respond to you over email. Okay? Thank you, and Kirti, over to you for Q&A.
Thank you, Srini. We have about close to 100 people joining us live. So thanks again, all of you, for taking the time. We have a few questions. We have one from Anshul that
Yeah.
how do we ensure guardrails set for explainability, drift, bias, factuality, etc., or in compliance with defined standards? Where are these standards defined and maintained?
Yeah. Probably I'll take this question. Right now, there are no set standards, at least that I know of, at the industry scale. But there are a few internal standards and metrics that we are following. Say, for example, when it comes to say a code generation, right? We typically use a lot of code generation tools today. We in fact are building our own code generation, where we know based on the industry research done by industry professionals. There are some really good research reports in ArcSieve, where it clearly says that variability should not be more than 15% for the same prompts, same input, and same input data, right? So that becomes one of the standards for us. So we typically tend to make sure that the variability of our outputs are within that range. And this is not a very strict, I would say. This is more for a code generation perspective. When it comes to say a marketing generation or a highly creative system, the variability will be quite different, and it could be higher. But there, if you ask, okay, how do I ensure? I mean, what kind of standards I put in a highly creative systems? There, you may not have a very clear standard in terms of a numbers or a guardrail threshold, but you look at some of the key messages, key assurance parameters, I would say, like say, for example, in a marketing brand kind of a creative system, you look at something like a tonality. Does it comply with your brand guidelines? Does the messaging does it have the right guidelines that you would see? Is that factually accurate to a point of what is that you want to convey? Is this crossing any thresholds in terms of copyright, IP rights, or some of the behavioral aspects, right? So those are things that we define. So again, that you cannot really have a industry-wide standard here, but depending on the type of the problem or type of the system we are addressing, we can define our own standards project to project, and we can assure quality around that. I hope I answered
Just
the
to add
question.
on, Srini,
Yeah.
ISO is also bringing in their own, just like they have for ISMS, QMG. They are also bringing. It's not at live, I believe. So, I mean, just a couple of days back, we were having ISO audits, and we were talking about this. So there is an industrial standard from ISO is also coming out for taking care of AI.
Perfect. Thank you, Sujata.
Yeah, we have one more from Tandra Chakravarti. From a QE standpoint, is there a maturity threshold or metric to decide what our training data volume and quality are sufficient for reliable AI performance? Maybe Sujata or Srini, you can take it.
Yeah. So in one, I can quote an example in one of the recent projects that we have executed, multi-agentic AI system, where we are looking at doing a bid estimation, a bid quote estimation. We are looking at least 1,000 past quotes, right? And if those are available, great. In fact, in this project, we got that. So that gave us a good spectrum of data for every variable that are used to generate the code. Say, for example, in this case, there were 5 major variables that goes into calculating the the code, final code. So for each of these 5 variables, we had a good amount of test data that helped us, I mean, look at all the variations within that data set to look at the quality. The same way, I mean, how far we want to go back, we restricted ourselves to going not more than 12 months, because in this context of the example that I'm giving you, we didn't want to go too far in the back, because the price changes over a period of time as inflation creeps in. The past bid might be cheaper compared to the bid last month, right? So we consciously took a call of not going beyond 1 year data. So there are some contextual elements that decides on how much, what should be the quantity of data, and what should be the temporal length of data that you want to take up, right? But generally, I mean, the larger the data set, the better for us, both in terms of training the prompts, right? I mean, I mean, as engineers, and as the the engineers in us, we also need to understand and probably have to use that to tune our prompt, but more data is actually required when you want to do some level of back testing, and you want to bring in all those knobs and weights to ensure for the continuous learning in the future, right? So for that, as larger the data set, as widely, a wide representation, it will definitely help.
Thank you, Srini. We have another question. So will these responsibilities fall under the ambit of enterprise quality function? Ankit, maybe you can take this.
Sure. I think when you probably what this question is trying to refer is the responsibilities that we talked about from a skill set standpoint, right? Because traditionally, if we think of it from an activity standpoint, it does sound like, and it actually is, that it would fall under the ambit of data and AI function. It continues to be the case, and it would be the case in future as well, right? But think of AI adoption from a life cycle standpoint. When, let's say, any AI system or workflow or any platform for that matter is being developed, right? A lot of the development activity, when it happens, it would be spearheaded by the AI team, the data team, and then those responsibilities, those activities, those skill sets would be something that would be need to be possessed by data and AI team, right? But in order to give you know shorten the trust deficit that we talked about, in order to give a go ahead, in order to give them a green light for these workflows from going from pilot to production, and then even after that, right, quality function needs to play a role there. Now for quality function, for them to play a role there, they will need to have expertise in those responsibilities, right? So net what I'm trying to say here is, it's not just quality team, or it's not just data and AI team, it's all of them having expertise in all those skill sets together, working in tandem across the AI adoption cycle, shortening the trust deficit, leading to enterprise AI adoption success. Hope that answers the question.
Yeah. Thanks, Ankit. You've got.
So I think we already had one question where there was a question on overall QA or test strategy that has been developed for testing agentic AI, and what was the consideration challenges. So most of the challenges we had already discussed, but let me just give a very high level overview on the strategy that we apply here to do the agentic AI testing. The strategy here is pretty simple. You have to test at different layers. Different types of testing also has to happen. So just like we do in the traditional system, here again we need to have unit integration system testing. So at unit level, we will have to test the micro agents logic. So each agent, in fact, while building itself, we should have built the agentic AI system in such a way that each process has to be singlered out and made into a micro agent, so that it all comes together live as a agentic AI system. So one agent, one action, that's it. So that's how we should have engineered the agentic AI system itself. So each agent at the unit level, we should have tested the logic thoroughly, and at the integration level, we have to test all the tools and API that connect them, and at system level we have to do end-to-end testing. So in the case of bid estimation that Srini was talking, we have to test the email systems, the ERP systems. So all these are connected to the agentic AI systems. So all these connections has to be tested in an end-to-end flow, so that we ensure the flow from start point to the end is proper. And finally, the orchestration itself. So the multi-agent flow has to be tested, and when it moves to production, the production has to be monitored. So the observability and retraining triggers. So based on the value fluctuations, we have to look at the retraining triggers as well. So overall, the approach has to is to combine the data sets. Data sets are really key, as the other person asked. So data sets play a key role in validating the AI. So the golden data set has to be there, and multi-run consistency test, and sandboxed tooling test, multi-step flow validation. All these has to be done, and a strong observability and drift monitoring and human in the loop controls will ensure continuous assurance as models, prompts, and data evolve, because these are going to keep evolving. So the complete focus has to be on the reliability, reproducibility, and
Just sorry.
controlled agent actions.
Yeah. Thank you, Sujata. Just to add, right, while we are talking about AI testing and probabilistic systems testing, I also want to emphasize that the current approach, the deterministic testing types and testing tools that we use today, continues to have a very important role even in testing probabilistic systems. It's not. It's a completely. I mean, what we are saying is not a completely different space. It's just a continuation to what we are doing today, right? Even in a probabilistic system or an agentic system that we build today, it actually, if you look at it, I mean, logically, there are three layers to it. One is the bedrock, or the ground at the ground, is still an engineering layer, right, which still continues to undergo the quality assurance that we typically employ in a deterministic systems, right? Then you have your inference layer, where you have the AI reasoning, the prompts, all that, which includes the new dimensions of testing that we are talking about, along with its testing types and tools like prompt hardness testing and so many other things. Then you come to the next level, which is basically the overall system, I mean, end-to-end testing, including the engineering layer and the inference layer, and also testing for the observabilities, governance, security, and all of that. So what I'm trying to say is, while we are focusing on the new dimensions of quality for probabilistic system, it actually integrates. It has to integrate with the existing quality frameworks and solutions. I mean, the systems that we employ for deterministic testing today. Yeah.
Yeah. Thanks, Srini. So
And
please
yep,
go ahead, Sujata.
there was one other question. Will we still write test cases, or will tools perform the testing? So you know. Tools performing testing is definitely going to be there, and test case writing, I won't say that it will be proper test case writing, because here with AI testing, it's going to be no single input going to be related to the expected result, but there has to be a validation with respect to the variations, right? So we will still have the scenarios that we need to validate, and different data sets that we need to use, and the band within which we need to have the results or the outputs. So it is all going to be there, and the tools to test the AI systems are also evolving. And we also, just like how we do automation for the statistical websites and other things, we also have to look at how we can evolve the automation for AI systems as well. These are all things that are evolving, still not in a matured state. These are all in a very budding state, I would say.
Yeah. Thank you, Sujata. I think we have two questions from Swati Lakshmi here. The first one is, how different is the testing method, human in the loop evaluation, different from traditional static testing that measures against a few quality attributes? Uh, I wouldn't say it's different, right? The human in the loop that we employ in a Gen AI system, uh, that actually, if you look at it, say for example, I can articulate with an example where the human in the loop here in the bid estimation implementation that I said is looking to check whether the bid code that has come out is actually something that looks similar to what they historically do manually, right? But for them to test it, they still need some of the dimensions that I explained before, like say, for example, explainability, right? So the system has to say, okay, I used this data. This was a missing data. So I used my reasoning and I assumed this and I calculated this. This is the provenance of these data and this is how I calculated, right? And this is my confidence in terms of what I calculated. So that provides a kind of a provenance and an explainability for the human in the loop to verify and understand how it was calculated and check whether the system adopted the sound scientific methodology or is there a issue with it, right? So human in the loop uses these 5 dimensions that we spoke to perform that validation here. Swati, I hope I answered your question. And the second question is, how do we handle systems with combination of AI systems integrated with other non-AI ones? Will it be a combination of traditional and AI QE approach that we should be adopting? Right? Exactly. That's what I was actually explaining as an extension to Sujata's response. Definitely, AI systems are built on or built along with non-AI applications. So the AI dimensions, test dimensions, and the frameworks that we are talking here is an extension to the existing frameworks, right? So you still need to test your, the engineering layer, which are usually deterministic in nature, using those deterministic tools and approaches that we adopt today. And then on the inference layer is where you bring in these new dimensions that we are talking about. So in the AI system, it will be a combination of both the current way of testing, or rather the erstwhile deterministic way of testing, plus the new dimensions that we explained. All right.
Thank you,
So,
Srini.
yeah.
That was insightful. Yeah. We are coming to the close of our session. So thank you all for joining us today. Again, a big thanks to Everest Group for co-hosting the session with us. So if you missed any of your questions, feel free to send them at sales@zucisystems.com. I'll type it for you in the chat. We'll follow up. We'll also share the recording and white paper shortly. Thank you again and have a great rest of the day.
Thank you, everyone.
Thank you, everyone.
Thank you, everyone.
Thank you.